Here's example number 3. Determine whether the given binomial is a factor of the polynomial. So we set up our synthetic division box. Here is our polynomial. It's a degree of 4. So we put our placeholders in: x to the 4th, x to the 3rd, x squared, x, and constant. Then we put in our coefficients. We have a 3, 6, and then now notice there isn't an x squared term, so you put a 0 there, then -5 and -10. Our binomial factor that is possible is x plus 2. So we set the factor equal to 0 and we solve it, so we get -2 minus 2, so x is -2. So -2 goes outside the box. Now we're ready to do our synthetic division. So we bring down the 3, we multiply 2 times -3, -6, we add the column and we get 0. We multiply 0 times -2, 0, we add the column, we get 0. 0 times -2 is 0, and we add the column and get -5. Then we multiply -5 times -2, which is 10, add the column, and we get 0. Notice this time the remainder is 0. So what that tells us is that this is a factor. X plus 2 is a factor of the polynomial. Because the remainder was 0. Example 4. Factor the expression and find the roots. So first thing we're going to do is go ahead and set the function equal to 0. And then what we want to do is we want to factor it. So we're going to go ahead and set up our box. We're going to put them in descending order. And then we're going to take out the GCFs of the rows and the columns. So the first column, the GCF, is x. The second column, the GCF, is 3. The first row, the GCF, is x squared. The next row is -4. Then what we do is we write the two binomials. So we have x squared minus 4, and then x plus 3. And now we're going to go ahead and use our zero product property. We're going to set the first factor, x minus 4, equal to 0, and the second factor, x plus 3, equal to 0, and then solve them for x. So we're going to add 4 here and add 4 there. So we get x squared equals 4. Then we're going to undo that x squared, so we're going to square root both sides. So we get plus or minus the square root of 4. And then we get x equals plus or minus 2. The right equation, we subtract 3 from both sides. And we get x to be -3. So we have 3 roots. The roots are -3, +2, and -2. Notice that the degree of this polynomial was 3. So we can have up to 3 real roots. If the degree was 4, we could have up to 4 real roots. If the degree was 5, up to 5 real roots, whatever that degree is. Here's another example. We again want to factor and find the roots. So the degree is 3, so we have up to 3 real roots. So we're going to go ahead and set the function equal to 0. And then put our terms in the box in descending order. So 4x cubed, positive x squared, negative 8x, negative 2. Then we take out our GCFs. So the first GCF of the first column is going to be 4x. The GCF of the second column, let's put positive 1. The GCF of the first row, x squared. And the GCF of the second row, negative 2. So there's our binomials. So now we write them in factored form. So we have x squared minus 2, and then 4x plus 1. Now we're going to go ahead and use our zero product property. We set the first factor equal to 0 and solve for x. So we're going to undo, so we're going to add 2 to both sides. So we get x squared equals positive 2. Then we need to undo that squared, so we square root both sides. We cannot forget the plus or minus in front of that square root. So our first 2 roots are plus or minus the square root of 2. You do not need to enter that into your calculator. You can leave it in exact form. Now we set the second factor equal to 0, 4x plus 1 equal to 0, and we solve it. So we subtract 1 from both sides. We get 4x equals negative 1. And then we divide both sides by 4. So our 3 roots are negative 1/4, positive square root of 2, and negative square root of 2.